Hello, and welcome back to Summarize Science, where we break down the latest research for you. Today, we're looking at a paper from UC Berkeley that asks a crucial question. Are AI models really as smart as we think they are? They introduce a new benchmark called SAGE, designed to probe the deeper, more realistic aspects of an AI's understanding. The problem is that current AI tests are often too easy, like an open book exam with no trick questions. They use perfectly clean data, but the real world is full of typos, strange formatting, and intentionally misleading text. This means we might be overestimating how robust and reliable these AI systems really are for everyday use. SAGE is different. It's designed to be a tough, realistic obstacle course for AI. It tests models across 5 challenging areas, such as their alignment with human judgments and their robustness to noisy text. For example, can an AI still understand the meaning of a sentence if you shuffle the words or randomly capitalize letters? It also tests if an AI can tell when you've inserted irrelevant junk text or removed important information. The researchers tested a whole suite of modern AI embedding models against older, classical methods, and the results are fascinating. Here in Table 1, we can see a summary of how each model performed across the 5 different categories. The most important finding is that no single model is the best at everything. There are serious trade-offs. For instance, OpenAI's powerful text embedding 3 large model was the best overall and great at understanding human preferences. However, it was only mediocre when it came to robustness. But the most shocking result came from its smaller sibling, text embedding 3 small. This model was the absolute best at grouping similar documents together, a task called clustering. But it was extremely brittle, achieving the lowest robustness score of all models tested at nearly 0. This means it's a genius in a perfect, quiet library, but falls apart at the slightest disruption. Even more surprisingly, older and simpler methods, like jagged similarity, actually outperformed the fancy new AI models on certain tasks. These classical metrics were much better at detecting changes to information and handling transformations in the text. It's a classic case of a simple, reliable tool being better for a specific job than a complex, sensitive new one. The paper calls this the benchmark production readiness gap. This means there's a huge difference between how an AI performs in a clean lab setting versus the messy real world. A model that gets a top score on a traditional benchmark might actually fail miserably when faced with the kind of data you and I create every day. So, let's quickly recap what this all means. First, today's AI models are smart, but they can be incredibly fragile and are not masters of all trades. Second, model selection is critical. The best AI for sorting documents might be the worst for dealing with noisy user input. Finally, we need more realistic tests like SAGE to truly understand AI's capabilities and limitations before we deploy them in high-stakes environments. Ultimately, SAGE provides a much-needed reality check for the AI community. It's a vital step towards building AI that is not just intelligent in theory, but also robust and reliable in practice.